solve the problem called word leader. It is a very famous question in graph algorithm. Okay, so we have been given a transformation sequence. So a transformation sequence from word begin word to word end word using dictionary word list is a sequence of words begin word, then S1, then S2, and then SK, such that every adjacent pair of words differ by a single letter. Okay, and each SI for I greater than equals to 1 and less than equals to K is in word list. And SK is equals to end word. So the point we are ending with should be end word. Now, given two words begin word and end word and a dictionary word list, return the number of words in the shortest transformation sequence from begin word to end word, or 0 if no such sequence exists. So what the question is stating is that we have to transform the begin word. We have been given two words, uh, one named as begin word and the other named as end word. Okay, and also we have been given a dictionary of words, means we can say a collection of words called word list here. Okay, and we have to transform the begin word to end word using the words present in the dictionary. Okay, and how we have to transform is that, suppose we started with begin word and we go to S1. Okay, so here a condition is being stated that every adjacent pair of words differ by a single letter. So the begin word and S1 should differ by exactly one character. Similarly, the S1 and S2 should differ by exactly one character, and so on until we reach the end word. Okay, and we have to find the minimum number of words we have to go through to transform the begin word to end word. And if we are not able to do so, then we have to return 0. Let's consider the example 1. We have been given a begin word is equals to hit and end word is equals to cog. Okay, and word list are as follows. Okay, so one shortest transformation sequence is we can go from hit to hot, and we can say that the only character differs is that here it was I and now it has become O. Okay, similarly, when we go from hot to dot, then here the only character differing is H. So now you have understood that only one character should differ when we go from one string to one word to another word. Okay, and now we have to do this transformation until we reach to the end word. So you can see hit, then hot, then dot, and then dog, and then we have reached cog. And uh, you should also observe that all the words are from the word list. So we now the, the question seems to be clear that we have to use all the you have to use the words only from the word list, and we have to transform the begin word to the end word. Okay, and we have to do so in minimum number of transformation. And if we are not able to do so, just in this case we have to return 0. Now let's see the constraint. The all the string length would have can have maximum length of 10. Okay, and all the word will have the same length in the word list, and the word list length can have maximum 5000 words. So the maximum 5000 words can be in the dictionary. Here it has been stated that all the word list I, means all the ith element in the word list, will have the same length as the begin word dot length. Okay, and one thing also important, that begin word is not is equals to end word, and all the words in the word list are unique. Now let's proceed to the solution. So how to solve this problem? Basically, here you can see there are some relations between each word to the next word. Okay, so you can think of making a graph like a structure in this case, in this question. But how to make the graph? till now we have only deal with the integers, and now we have to deal with the strings. So okay, what I will do that I will if suppose I have a word, then I can store all the words which which can be its adjacent neighbors. And what is the condition for being the adjacent neighbors? That the neighbor and the parent node uh, should have exactly one characters differing from each other. So I can say that here hot and dot can have an edge between them because only one character is different, that is H and D. Okay. Similarly, dot and dog can have a edge between them, and dot and lot can have a edge between them, and lot and log can have a edge between them, and cog and dog can have a edge between them. So in this fashion, we can build our graph. Although we do not require to actually build the graph, uh, I will tell you the approach where you don't actually need the graph, but you will proceed the solution in this manner only. Okay, so let's discuss the solution. Uh, First of all, it has been stated that it might be possible that the starting word is not itself present in the word list. If that is the case, then obviously we can't reach to the end word. Okay, so I will first take a unordered map or a set, whatever you can take, st named as st. Okay, for now I will push all the string present in the word list. Now I will check if st dot not is equals to st dot count and word, or not is equals to st dot count not is equals to st dot count begin word, then we have to return 0. Why I have written this? Just initial checking, I am checking that if the end word or the begin word is itself not present, then what's the meaning of means searching from the means the transformation from the begin word to the end word? We would have to return 0. Obviously we would have not found any transformation sequence which can transform the begin word to the end word, so we would return directly return 0. Okay, and if this is not the case, then till now when we were dealing with the integers, we were maintaining a adjacency list, but here I will have to maintain an ordered map. Okay, unordered map, something like the visited array, as in the case of the integer graph. Okay, I will store here the distance, means this the distance of the for given word from the beginning word, because at the end we have to find the distance only from the begin word. Okay, now I will apply BFS. I will first insert the starting, means begin word, uh, sorry, and I will mark the distance of it as 1, because if although it's not possible. Okay, so now we would perform the BFS. Suppose string current string, we how can we get q dot front, q dot pop, we will pop the current element, on the queue. Now how to access the neighboring string means the string we have to proceed on. How to determine this? For this, what I will do, for int I is equals to 0, I less than current dot size I plus plus. I will explain you what I am doing. First I will keep a copy, int temp is equals to current. Okay. For char c is equals to a, c less than equals to z, and c plus plus. Now what I will do is that uh, I will just transform every character one by one to a particular character from the for all the alphabets present in the Latin letter. Okay, means all the letters present in the Latin letter alphabet. What I mean that, suppose I am at a hit, I am at a word hit. So what I will do, first I will transform for first position means from A to Z, and we'll check if this string is present, if this word is present in the word list or not. Okay, so, suppose I transform H to L, H to L, or A means I am transforming from A to Z, means I will place all the characters one by one from A to Z, and we'll see whether this word is present in the word list or not. And you can see when I will transform this H to L, then I can get a word in the word list lot. Okay, similarly for each of the position I will do the same. That's what I am doing. Okay, in this way I would not require to means pre-store all the adjacent uh, nodes which can be neighboring nodes of a particular node. Okay, now I will do temp of I is equals to c, means I am changing this character at this position to the character c, means okay. So if st dot count means if it is present in the word list, st dot count temp, and if it is not visited yet, then only I have to go on it, and not distance of temp. Then what I will do, dist of temp is equals to dist of current string means the parent node, because what I am doing here, if this can be considered as the parent node, and now I am traversing through all of its child which can be possible child for this parent node. Okay, and I will push this temp as we usually do in the BFS traversal. Okay, and after all this, first I will pre-store char c which is equals to char of, by because I have to also maintain this current string for the later traversal, means for all the positions from I is equals to 0 to I less than current dot size. Suppose if you have modified the current string in the at the index 0, but then how will you keep track that it was the same string for all the indices? So that's why I am doing so. Now after all this modification, at last I will do temp of I is equal to ch, means I have restored the uh, current parent node. Okay, so yeah, okay, now I would just return distance of and word. So this seems correct, let's run it. One case has been passed, other has not been passed. Okay, So what's the issue here? I have q dot plus begin word, then distance of begin word is equals to 1. Then I have okay. Now string temp is equals to current. Then I traverse from the I is equals to 0, I current dot size I plus plus. Then I store current of I. Then I change temp of I to C. It should not have been failed, but okay. I is equals to 0, I less than current dot size I plus plus, and now character C is equals to A, C less than equals to Z, and C plus plus. Then I have changed the character at this position, and I check and did this exist in the word list st.count 10, and not is equals to distance of 10. Okay, then distance of 10 I have modified to distance of current plus 1, and now I push the current string into the queue. Temp of I is equals to ch. So that was the problem, but why it was st.count, not st.count begin word, return 0. Oh, sorry, it's not been necessary that the begin word will always be in the word list. Means we have to transform the begin word to the end word, but it's not necessary the begin word will always be in the word list. In this case, it was not present in the word list, that why is what returning 0. So one thing, if you want to check, then this condition should be omitted. Okay. if you run this should pass. Uh, oh, sorry, it should be end one. I have omitted the wrong. Not is equal to dot end one. Now it should work fine. Okay, accepted. Let's submit it. Yeah, it got accepted. So let's talk about the time complexity. So what we are doing, we are just running a BFS, and for accessing all the neighboring nodes, we are running this code. So what can be the maximum time complexity of this code? We know that each word length is maximum 10, so 10, and we are just checking for all the alphabet, and there are 26 alphabets, so it would be 26. Okay, and you know that another set and another map take constant time, so it would be this only. And for running the BFS, we are using a queue and accessing each word for at least once. That's why it would take the number of word length, so it can be at max. So let's consider it n. So yeah, this much it would be time complexity, and this n can be at max 5,000. Okay, and talking of the space complexity, so we are storing all the strings in the set and the map, so it would be big of n itself. It will also be linear. Okay, so yeah.